Hello and welcome. Today we'll be looking at Divvy Trips data, just some of the analysis, data cleaning, data wrangling manipulation that I did on it, and my attempt at some statistical analysis, specifically a t-test, and I'll get to that one at the end. But without further ado, we'll jump right in here. So we have a couple of notebooks today that we'll be working with. One is the Divvy Trips EDA shortened version. So what this means is basically we'll be utilizing and taking a look at a fraction of the records. We won't be looking at all 7 million records for 2018-2019 Divvy Trip data, but we'll be taking a look at just a portion of it. And the reasoning for this is that it allows us to, one, make sure that our code is working and easily make updates and run specific cells within the Jupyter notebook and not be bogged down by the amounts of data. And maybe it's just my specific scenario where I don't have a lot of horsepower behind my laptop. So if I did, I'd probably be able to run it on all 7 million records. With that said, I do have this full Divvy Trips data notebook, which is the same thing, except all of the code and visualizations are ran on all 7 million records. So this gives a holistic picture. The shortened version is a way for me to talk through this video of my code, my approach to the data cleaning, data analysis that I did on this. So the data set specifically came from a public data source called divvybikes.com/system-data, and it just gives you a brief overview of what the data is. We'll dive into the details of what kind of columns or fields are in the data. But you can go here, and I'll put a link on the description, but you can go here, download the data. You'll see that there's a lot of years. I only downloaded 2018, 2019, and that in and of itself gave me 7 million records. So I'm sure you can go in and go crazy and really look at a larger historical picture of Divvy Trips data. And Divvy specifically, I think, operates in Chicago, and this is what that data shows. So with that said, let's get started. So some of the things that we're going to cover, we're going to take a look at the data. We're going to do some sort of manipulation and cleaning of it. I'll talk in more detail of what that means. Not necessarily, the data in and of itself is pretty clean, but there are some things that, like if I wanted to generate a new column for just easier manipulating or maneuvering or creating visualizations, I did that at some points. The data source is here with the link. So what's in the data, this is from the actual link, but every trip will have a trip start and end time, a trip start station and end station. There's some other data like gender of the writer, whether the writer type or the user type. There's a discrepancy in what they tell us that it'll be and what is in the data for 2018-2019. But this just gives a really brief intro to the data. It doesn't really do justice to it, but that doesn't mean that we can't go ahead and find out for ourselves. So the first thing I did was just import some libraries that I'll be using, mainly pandas, matplotlib, seaborn, and numpy. There is a calendar and date time that I used for parsing out like the date or the day and the month and such, and we'll get to that in a bit. GeoPy to get the distance. At one point I wanted to use this to get the distance between the stations, but I used a different method, and I'll get to that as well. Penguin for the t-test. Then I imported Folium, which was what I used to create a quote-unquote interactive map, and I'll show you what that looks like as well. And a lot of these plugins from Folium in order for me to be able to create those interactive maps. So with that said, I'm actually going to go ahead and run it here. Perfect. So I like to use this HTML code to add a border to my tables. It makes it just easier to see the rows, the columns, and discern whether something's a header or not. But I just run that. So first thing I did, import, examine the data. There was another data set called basically this Divvy stations, and it's within the data source. And what the stations provides, it has 688 records, but essentially, I can take a look at it here. It gives you the ID of the station. So within the trips, there will be an ID for station start and station stop, basically where a bike was checked out and where it was checked in. With the station name, the total docks and the docks in service, the status, which is there's in service and not in service, latitude, longitude, and location, which is these two put together. So pretty standard, pretty clean. There's really not a lot to it in terms of parsing out or going in here and replacing some I don't know, like a parentheses for a space or whatnot. So it's pretty clean in and of itself. So I left it as is, but I just wanted to give you a quick overview of that. The next thing I did was I imported the Divvy Trips data. So I did this using a for loop, and the reason for this is, one, I was lazy to actually hard code everything. There's 8 files, 1 file for every quarter. So there's 2 years, 2018, 2019, 4 quarters. So there's 8 total files. So if we look at the data, I'm going to go back up here real quick. So I'm going to open this up. There is every file that I downloaded, there is a year and a quarter. So from 2018 to 2019. And it just so worked out like that, right? Where 2017, it doesn't have that such format. So that worked out in my favor, and I kind of took advantage of it. So what I did first, I created this variable called trips, and I imported just one CSV as a data frame. And the reasoning for this, you can see the n number of rows here is 0. I just wanted to get the name of the columns. And the reason for this is I found out is that some of the columns are spelled differently. And so when we get to the for loop and we're trying to concatenate the data frames, we needed the columns to be the same. So that's why I did that. So I got the name of the columns, and then I assigned it to this column variable here. And then I reset the trips data frame to be blank, basically saying, give me the columns, assign it to the columns field, which I could have done in one swoop. But anyways, and then reset the trips data frame. From there, I created this list of years. So basically saying, creating these 2 years as a list, and then the quarters lists here for quarter 1 and 2. So for every year, that's when I started the for loop, for every year in the years list, so for 2010, 2019, and for every quarter within that year in the quarters list, create a temporary data frame where you read a CSV with a file Divvy Trips _year_quarter.csv. For this instance, I'm importing n number of rows, which is 125,000 for first 125,000 rows from each file. There's a lot more. If I wanted to import all, I just remove this code here, but I'm gonna leave it as is, and then take that temptf and set the column names equal to column. So I found that the columns are the same order and should be the same name. Some of them are just either capitalized differently, so we need it to be exactly the same. So that's what I did here, and then take the trips data frame, which is empty or basically the existing data frame, and then concatenate the temporary data frame. So basically take the existing trips and the new temp data frame and concatenate them on axis equals 0. So you're concatenating them vertically instead of side to side. And I did that for every quarter and every year. And so once you run this, in my instance, I'm expecting 8 files, right? So, 4 for 2018, 4 for 2019 at 125,000 each, so 1 million total records. That's how big my final data frame should be. So this ran successfully. I can take a quick look here and show you that, yep, there is indeed 1 million rows. So I ran this trips.head just to get a quick glimpse of the data and making sure that things imported correctly. You can do a couple of things if you wanted to look at a random place in the data frame. I can do like give me 125,000, so I'll do like 130,000 to 130,010, and that gives me this. So it gives me those 10 records from the 130,000 to 130th. So and yeah, everything looks good. You can do a quick spot check as such, but I'm going to leave this as .head3, and again, the reasoning behind this is I wanted to make sure that everything looked good, and it also gives me a chance to look at the data and say, okay, so for trip duration it's 323. I doubt it's minutes. It seems like it's going to be seconds. 2,904 minutes, not likely. So if the data dictionary or whatever, since it's public data, maybe not, it doesn't have one, so I'm going to go on a limb here and say this is likely seconds, which makes sense. You would track it on a seconds basis, especially if you're charging per minute rate. So once we have that, I took a look at the stations data frame, and this .info gives me a couple of things. One, how many records there are, but two, the data types for each column, so you can see the ID is in 64 and so on and so forth. And then the third data point or info this method gives you is how many non-null, so how many not empty records are there. So there's 688. So basically out of the 688 entries, there are 688 IDs, which is good. That means that there's no values for this in all of these columns. As expected, I said it's pretty clean, so that's good news. The same thing for trips.info. If I run that, it gives you all the data, but then you get to this point where it says gender. There is 868,595 values in gender, so the rest are null. And same for birth year. So if we wanted to look and confirm, we can run this trips.isNull.any, and this basically gives you a true or a false for every column. If it's true, meaning there are no values. If it's false, then there are no null values or NaNs for this. So this confirms that up there, that gender and birth year have null values. I can take a quick look at gender and do this trips.gender.unique, and gives me the unique values of gender. So for this one, we have male, female, and NaN. And non sounds really good right now, but not the point. Let's move forward here. So I did the same for user type, and it's subscriber and customer. So this seems similar to what they were speaking to or alluding to in the data, in terms of writer type, member, customer. So this seems about right. There is no NaN, so they're either blank for whatever, there is no value. It doesn't have NaN, it just has a blank value. So with that said, I went ahead and I created this quote-unquote dictionary of the columns for trips. I mainly will be working with the trips data frame. I'll be using the stations as an appendix and being able to kind of add on to this trips data frame, right, and be able to work with the data in this trips and give it a bigger dimension. So with that said, I wrote out kind of the columns here and the intent or the purpose of each. Trip duration is in seconds currently, from when the bike was checked out from one station to when the bike was returned at an end station, or what they call it, a to station. So on and so forth. In terms of gender, as we saw, male, female, so that's not something that we decided. It was something that maybe the app developers decided. So it could potentially open an opportunity for us to question whether they are actually offering the ability for users to select any gender identity, or if it's just male or female, and that constraint. So with that said, we're just describing the data, and in terms of the gender and the birth year, there's a couple of options. So speaking to specifically the null value. So when we have null values, a couple of things that we could do. One is to impute the values, meaning we can take the existing data and impute gender. Maybe there is something else, another variable, like even for user type, or let's say that a missing value was age, and then we had a column called birth year, as we do here. Then we can impute the age based on the birth date or the birth year. But for gender, we can try to impute the gender variable for a missing gender value, but there's a downside to that. One is that you may be inserting bias into the data frame or the data, and two is that actually having a blank value in gender may give you some sort of information, right? So no information is, to a certain extent, information, in that you may be able to create a separate category for people who didn't provide a gender. Maybe they didn't provide a gender because they don't identify with either male or female and they don't want to enter a gender, or they're just a customer who's using it as a one-day trip, so the app didn't capture any, or the trip didn't capture any sort of user data, and that could be the case where there's no gender and no birth year. Maybe the user wasn't registered in the app. So there's a lot of what ifs, and we don't have access to the business resources to ask and confirm these assumptions. But I made a decision just not to impute gender and not to impute birth year. And the variables, even though they are missing, I could use them as a different category, right? And maybe say there's male, female, and then gender agnostic, or just a different sort of approach to say, instead of saying, oh, we're missing data, is we just have a different group that didn't provide a gender. And it's also difficult to impute. It may take more. If we wanted to do impute, we probably could get the mean, the median, or just take other data set and try to predict what the gender would have been. With that said, that's just my approach. I'm not going to dwell on it any further, but the first thing I did after that, just to count and confirm how many null values there are for gender and for birth year. So if I run this here real quick, there's 100. So out of the million, there's 131, 405 null values for gender, and 871, 779 records with non-null. And same for birth year. Fascinating. Okay. No values. Okay, so I made a mistake here. I entered gender, that's why those two numbers are the same. I was like, this is not adding up. Okay, so if I enter gender here, now it gives me, and everything adds up. These two should add up to 1 million. Perfect. Okay, so just a quick data point confirming, and we move on to a lot of the quote-unquote what I call data manipulation and cleaning. The data in and of itself is pretty clean, but this is a section where I went in and I try to predict, okay, what am I going to do with this, and where can I potentially clean it? So did a quick trips.head just to give me the first 3 records. Again, always want to have a good idea of what the data looks like, the columns. Then user type, I did that again for some reason. So the data types, a lot of times what happens is when I think the reason I ran this is that I wanted to see what the data types were so that I could confirm either like that's the expected data type, right? So for example, let's say, let's see here, start time, it's object, end time is object. I'm not sure if I can actually do any sort of deduct or extract like the year from this if it's an object. So I may have to change that to a date time. The bike ID, it's an int, trip duration, it says object. I really want this to be a float or an int. the reasoning for that is that if I want to do some sort of mean average, I want to make sure that it's malleable and I'm able to do calculations on it. So that's one of them. So I went through every column and I just assessed, okay, which ones do I need to? And one of the things that I came across, once I started running it on all 7 million records, then it became, for my computer at least, a memory issue. Like I was running out of memory really fast, just because I was either copying the data frame or and such. So what I did was actually take the trip ID, so anything that was a int, and creating it and turning it into this numpy uint8. It takes less memory space, if that makes sense. So I did that, and then for the gender, I changed it to a category type. So I did this trips gender.asType, setting it to itself. And the reasoning for that, it is a category. And two, once I get the category, I can create these category codes as the encoded variable. So I did that for gender and user type. And once I do that, if I run this dtypes again, theoretically you'll be able to see this change. Perfect. And then category for user type and category for birth year, which is a good thing. Now, once I have the category, then I can do this creating or assigning an encoded variable and as a new column. So I did gender_cat for category, or cat for cat. But I did that for gender and user type, and it's pretty simple, trips.cat.codes, and this assigns a code to every value. So if I do that, and then the expectation is that there's actually a new column, so I can actually go back here in the data types, run this, and then you'll see, okay, yes, there is a new column. And then two, I'm able to go in here and confirm, okay, there is a gender category column here. A 1 corresponds to a male, 0 corresponds to gender female. And the reasoning for this, a lot of times, if you wanted to do like a correlation analysis, typically categorical against a numerical variable, you wouldn't be able to do a correlation analysis. But if it's a gender category, you would be able to, or it's just easier and it's helpful. So I did the same for the user type, where subscriber is 1, and the other user type, which would be customer, I guess is going to be 0. So once I have that, then the next thing I calculated, I created a new column called trip duration. And actually it wasn't a new column, it's just a replacement of. So what I'm saying is go in, replace this number by dividing the number itself by 60 seconds. That will give us the number of minutes. But before I could do that, because this is an object, it has some of these commas, I needed to remove the commas, right? So just to make sure that I could change it as a float. So that's what I did here. Basically said, take the trip duration and did this dot apply lambda x, and x being for every value in this trip duration column. Apply this x dot replace every comma with basically a null, blank, no, not even a space. And after you do that, then change the column type to float. So once I run that should be pretty fast. Yep. I did just a quick check to make sure that it worked. So float, perfect. So that worked. Again, it was up here. It was an object, right? Trip duration was an object. So we are good to go. The next thing we did is so I was anticipating I was going to need to merge the stations data frame to this trips data frame, and I was going to merge it on either from station ID and to station ID. So these are the station IDs which match the ID of the station's data frame. So I created 2 data frames from that station, One is stations from, and one is stations to. And the reasoning for that is I wanted to have two columns. So for example, just like it does here, from and to, I wanted to have from station location and to station location, or from station longitude to station longitude. That way it's not just one merge, it has to be multiple merges. So I created these two data frames, and what I once I created them, I appended into the column names these from and to, and turned them all lowercase. And a lot of this manipulation and just pre-work was to be able to merge them, and to be able to control and have and for me to know which ones are the from and which ones are the to stations. So once I did that, then I removed these. Well, the reason I dropped these names, the from station name and from location, is that, well, for location it's actually the longitude and latitude, which is already in the data frame together, so I didn't need it. From station name, I already have the station name up here and two stations, so I didn't need that either, and it was just wasting memory. And when I was running on 7 million records, it really got really slow. So I was trying to save as much memory as I could, so I did that. Okay, so this next one is the actual merge. In the actual merge, I take the trips and I first merge it with the station from, doing this trips.merge, stations from. How is the left merge? So the left data frame is trips, the right data frame is stations from. So it'll merge left. And left on, I basically call out where from station, or on from station ID, and right on from ID. So if you are comparing this to SQL, you would typically do like left join stations from on trips dot from station ID equals stations from dot from ID. So that's what I did, and then I did, once I have that data frame, then I took that existing, or the new data frame, and then did another left merge with the stations too. So I will have the trips, left merge the from, left merge the to. So theoretically we'll have a lot of columns, but enough data for us to be able to do some mapping and things like that of where into people went. Once I do that, it gives me this trips.head, or I actually ran this trips.head just to make sure that everything imported correctly. You see on here, Jupyter Notebook does a funky job of saying ... So I know eventually here there's a from status, from latitude, to latitude, or to longitude, to ID. So theoretically these to ID and the to ID should match, and the from ID and the from ID shouldn't match. So that is good news. If I wanted to confirm that, I'm just going to open a quick notepad here. I can take trips, and let's say I want from station ID, and then from ID, and then to station ID and to ID, right? So from station ID, from, just a quick sanity check for me, right? To station ID, and then to ID here. Let's see what that gives us. Perfect. So that, okay, that's a good, looks good so far. So that from ID, to ID, looks like it's a match. This matched. So it matched on the left, but then on the right, there was no match. Fascinating. Okay. So this is the quote-unquote, not final data frame, but the pretty close to a final, I should say. And I ran this .columns just to take a look at the columns. Everything looks good. So for saving memory, I deleted the stations to into stations from. Not necessary now, but you know, when I was running into memory issues with the 7 million records, I was trying to cut corners, or not cut corners, but save space, memory space where I could. So I did that. And then, given that these from station, they're duplicates, right? So I actually dropped from ID to ID, from total docs to total docs. And the reason for dropping these to total docs is I didn't end up using it at the end of my notebook. So I thought, well, at least this time around for this analysis, I don't need these columns, so I'll drop them. Yes, you can definitely do analysis on the total docs and whatnot, but I'm gonna leave it as is for now. And even though we're dropping those, we still have these docs in service, which I mean, it's still, if you wanted to take a look at the number of docs, quote unquote true docs that the station has, that's a good column to use, and that's what I did. To status, from status, for active or inactive. I just treated it as like, if the trip happened and this station is no longer active, but it happened before, then I'm just gonna say it really doesn't matter. It's a trip. It recorded it. I still want to know where it started or where it ended. So once I had that, then I began the quote-unquote basic EDA, which is essentially saying I'm going to ask some questions to myself, or some questions that I want to answer with this data, or what can I answer with this data. And there's a lot, but not to go down the rabbit hole, I came up with these 9 questions for no particular reason, just trying to explore the data, trying to get some insights, and seeing what I came across, right? Some of these actually arose like, oh, I'm actually going to need a new column to answer this question, but we'll get to that. So the summary stats and count plots, just basic, tell me how many counts there are. This is typically for the categorical variables. Male versus female. Given that we do have male and female genders, it would be, I thought it would be good to say, what is the average duration of trips, the average distance, the distribution of subscriber versus customer. We took a look at the popular stations to and from. What are the trips by time of day? Do they differ? What are the trips by month? Is there a season? Which is Chicago, which I'd imagine, and my theory is that it would be, but this is a question that we could answer with this. Trips of subscriber versus customer. Again, just working off the data they gave us, this is a question we could answer. The difference in trip count by weekends versus weekdays. We have the dates, so we should be able to find this question, an answer to this question. The distribution of trips by subscriber age. Okay, so yeah, we'll get to that point as well. Distribution of trips over 45 minutes versus under. And the reasoning for this specific question, I was actually a subscriber, remember myself at some point, and after 45 minutes, at least for subscribers, they charge per minute. So I was curious, how many, so do subscribers actually go over the 45-minute mark? If so, how often? And so I wanted to answer that question. So let me pause there for a quick sec. So, the first question, summary stats and count plots. What are the summary statistics for all the variables, really, and what is the count distribution for all categorical variables like gender and user type? So that was the question. Pretty simple and easy way to get summary stats. Trips.describe. It'll give you a quick count, mean, standard deviation. The minimum, 25%, these quartiles, and then the max. So you're able to take a look and say, okay, so bike ID, really the min and the max, it's things like that, where it's specific and maybe randomly generated. So this is actually not telling us a lot of info for these trip ID or bike ID. Trip duration, that may be good info. Same thing for all the IDs. The birth year, so birth year here, let's say the minimum is 1899. So it's 2018, 2019. I doubt somebody 100 and, I don't know, 100 and whatever time they whether it be one year or the other, over 100 is actually riding a Divvy bike, but maybe just a user who didn't bother to select a year and they just selected the very lowest year they could, or they don't want to give an age. A lot of things. Average age 1982, which is 35. 25%, 1977 to 1986. That's the 50th percent, so the median and the max, 2003. Okay. So, same thing for, what other? Docs and service, where the max 55 docs, and then the min, I think it's 19, or actually 7. So one station actually has 7 docs. That's close to nothing, but something. But yeah, so this gives you quick stats. It's pretty simple, very easy, trips that describe, and then from there you can, like we observed, okay, birth year, like something's going on, something's fishy here. With that said, continuing on the question, the count distribution, I ran this code, which is basically we're using Seaborn. So we're setting this plot.figure, which is the figure size, 1510. And I could set this to 1010. I'll show you what that looks like. But then we set the number of where the variables that we want to look at, which is user type, gender, and birth year. And for every, okay, so we're using enumerate. So we're saying for every number, so we'll start at 0, 0, 1, 2, we'll number these. And every variable, so in our cases, for every user variable here, user type, for gender, and for birth year, and enumerate vars to look, plot, give me a subplot, and this 3-1 says it's going to be 3 rows, 1 column, and add a I plus 1. So we start with 0, so plot the first one, and this first, second one, and second, and so on and so forth. This actually, we don't need it, so we should be able to comment this out. And then after we create this subplot, then we do this basically plot in the subplot, this count plot from trips var. So what trips bar does, if I actually do it here, trips, and the var is user type, just gives you this series of either a subscriber or customer. So you're able to see, and this count plot basically counts every different or unique, I guess, instance within the column or series, and gives you a count of it. And then we add a title saying count plot of user type. So that's its magic. It's a for loop, pretty awesome. And then it does that. So you see subscriber out of the million, about a little over 800,000 are subscriber, about over 100,000 are customers, and for gender, a little over 600,000 are male, and over about 200,000 are female. So the age, or the birth year, I guess, at this point. So birth year gives you a count of, I mean, there's a lot of, this axis is just very busy, but this is what the birth year. So I would imagine over here on the very left is that 1899, and then on the very right is that, I think, was it the max birth year, 2003. So, and everything in between. So that gives you a good idea of maybe what the distribution of ages looks like, how many male versus female, which is actually interesting, right? Because, I mean, obviously the population distribution of male-female is not as such. So there are definitely a lot more male subscribers, at least within the subset of the data. And I can confirm that in the 7 million records, it's very similar and I'll show you over here in this other. So this is actually all 7 billion or 7 million records, and you can see the plot are very similar to the 1 million records. So there's not a lot of differences. Even if we add another million, the ratio would be pretty similar. So that answers that question. Now, in terms of male versus female, what is the average duration of trips, male versus female, the average distance of trips that males take versus the females, and distribution of subscriber versus customer for trips where the gender is male and female and such. So, for this specific, I quote-unquote added a new column, but I basically took the trip duration column and divided it by 60. And that way I got it in minutes. And I think it's easier to comprehend from a user perspective what in minutes would it be, right? So if I told you like, oh, the average trip for a male is 1900 seconds, you'd be like, that tells me nothing. Like, I really can't picture it in my mind what 1900 seconds looks like. What is the duration of that? Where if I told you, oh, it's average trip is 45 minutes, then you'd be like, oh, okay, that's a long time, or that's a short time, or it's just easier to picture how long in duration, at least for a bike trip, right? So if we're talking about 100-meter dash or whatever, then you would definitely use seconds. But for this instance, trips in minutes, at least for a bike ride, seems about right in terms of the metric that we would want to use. So I did that, and then I went on to answer the question. So what is the average duration of trips by males versus average duration of trips by females? So pretty simple, and this is kind of my go-to, is this group by function. So I did trips.group by gender, and I took so basically group by gender, male, female, and take the trip duration for each group and give me the mean. And so once I ran that, it says, okay, so for female, the trip duration average, did I run this? There you go, much better. See, it wasn't 1100 minutes. So 18 minutes is the average trip duration for females, and then 14 for males. So it seems like females ride, at least based on this mean, it seems, and I say seems very loosely here, that females ride on average 4 minutes longer than males. It may just be that they check out a bike and for 4 minutes they're getting ready, or maybe they're just, again, we can't make assumptions here. We're just taking a look at the data, extracting this data point, and saying, okay, this is what the data is telling us. Where can we look and dig deeper? So the other thing that I wanted to look at specifically was this. Well, trip duration count is kind of like the trip count, really, but how many, let's see if that's actually true. So yeah, okay, so I wanted to get the number of trips by male and female, and the reason for that is that if we have one trip by a female that's 25 minutes long, then the mean is going to be 25, whereas if males have 1 million trips, then it may just be that the reason that the female mean is higher is because there's less data, and one outlier may influence that specific data point, right? So I did this group by gender and then just counted the instances of trip duration, which is at 206, 125, and so there females took from this million trip subset on average 206,000 trips. Males, not on average, but in total in the data set, there's 662 trips taken by males and 206,000 taken by females. So this is the same thing as if I did a trip ID. Basically say, give me the count of trips for gender. So this is expected, right? Because we counted up here and we did this plot. So this gives us the specific number. So, I mean, it's still a large number of trips, so I would imagine that this is still pretty significant, but we can do a test later on. So takeaway, women take less trips than men. They do. So at least there is, on record, less number of trips taken by females. And this could be just because maybe, I don't know, if let's say in the instance that a male takes a trip and then checks out a bike for their female friend, is that counted as 2 male trips because the same user checked out 2 bikes? That could be. So we don't have access to the business context, or at least people who can answer that question for us, so we'll just make assumptions on the way. But with the woman's average trip duration is about 5 minutes, well, in this case 4 minutes, I think 5 minutes. How much was it for the 7 million? I'm interested now. So for 7 million, for all 7 million records, 2018 and 2019, the mean was actually a little bit higher, right? The difference at least, 4 point something, so 4.8. Whereas this, it's about 4.2. Anyways, so that's the takeaway for this. Now the next question, the average distance. So females are riding a bike longer, and so once we got to the distance, it got kind of tricky, right? Because we're trying to find out what is the average minimum distance ridden from start station to stop station. Or start, or from and to. And how does it compare, right, between the males and the females? But in terms of what happened in between from and to, that we really don't have that data, right? We don't have like, even if it's checkpoints, right? We don't have a latitude and longitude checkpoint as the trip progresses, right? So we just have where it was checked out and where it was checked to. So I created a column called minimum distance traveled. So what this says basically is that if I take the location of the start station and the location of the ending station, and I take the distance between the two, then theoretically that is the minimum distance at minimum that the trip or the rider took or traveled for that specific trip. They could have traveled 10 miles in between, but if the distance is 1 mile apart, at minimum they traveled 1 mile. And again, this is all based on the limitation of the data. It could be that if I worked at Divvy, I might have access to actual checkpoints or the actual route and the actual distance ridden. But for this specific, I had to calculate it, and this is the route I took, and that was my reasoning. So you don't have to agree. You don't have to do it this way. If you have a better way, I'd be happy to hear about it and discuss it with you. But anyway, so I found this function. So this is where actually I wanted to use one of the libraries, but I found this function where you basically pass a latitude, a longitude for the start, and in my case, and then latitude and longitude for the end. You set the number of miles, so, or miles is this number 3959, which I'd imagine is some sort of divisor, like kilometers is 1000. So you basically you pass in the latitude and longitude for the start and the end, and then it calculates this variable dlat, which takes the latitude of the end minus the latitude of the start, and same for the longitude, and then it's like a quote-unquote Haversine function, and it runs this numpy.sine difference of latitude divided by 2 squared plus numpy.cosine latitude 1. So it's basically a formula to Haversine formula. I think that's what it's called. I'm not sure if I'm pronouncing it right, but after much headaches and troubleshooting, this is what I found. So I guess I should put it here. My code, but very handy, and I came across it in a Medium article. So let's see. Let's move forward here. So once I define this function, I'm returning the total number of miles between the 2 points. Once I have that function defined, I went in and I created this trips minimum distance traveled is equal to, funny enough, I named it the same as the function. I call the method, or defined up top, and I pass it this trips from latitude the values, and the trips from longitude values, and the trips to latitude values. So, and trips to longitude values. And the reasoning for this, and I'm not super versed in this, but I was doing a for loop before, and it was taking a very long time on 7 million records, at some points crashing my kernel. So passing this is like passing this is like a numpy array, and from what I was reading, this is a vectorized way of passing the values so that we are not looping, or we're not passing the entire data frame into the method. So if I run this, 86 milliseconds for a million records is pretty good. So this is the route I took. Now if I wanted to see, okay, what happened? So it ran successfully. Now if I do trips minimum distance traveled, okay, perfect. So there is that NAN. So basically, if we pass it an NAN, we'll get an NAN, because if we don't have a latitude or a longitude, that would be an issue, right? We can't get the distance. So it gives us in miles how many miles it is from. So this is good. If I wanted to go so far as to say, well, 0.434302, and let's say then I now have this 2 latitude and 2 longitude, and from latitude and from longitude, I could actually quote unquote check this and make sure that it's accurate. So I'm actually going to do that. Okay, so I did a quick check. So I googled calculator for distance if I have a latitude and longitude, and I got this geodata source. I input this from latitude, from longitude in this origin, and then the from or to latitude to longitude in this destination, and then I clicked miles and click calculate, and it gave me this distance between the 2 points, 0.43 miles. If I run this, ta-da, which is good news. So this seems like it works, which is good, because I assumed that it did. So once I have that, then I changed the result, right, the total miles, to a float, because it's just to make sure that I was able to, if I wanted to do some sort of aggregate or calculation on it, I could. Then once I have that, then I can actually answer my question: is what is the distance traveled between, where is the difference in there, the mean distance traveled by trip for males and females. So I ran this code, and it seems like the mean distance traveled by female is 2.0, whereas male is 1.8. This sort of aligns with, well, if females are taking longer rides, you'd think that the distance traveled is longer. Again, this is just based on the check-out, check-in. So if they took a bike from station 1 and they returned it to station 1, the distance traveled in this calculation is going to be 0, but we know that they probably traveled maybe whatever it is over 0, because unless they checked it out 10 seconds later. But I digress. So, the next question, of all the trips for 2018 and 2019, how many are male-female customers and how many are male-female subscribers? So, pretty simple. We already have that data. We have the columns that we need. So, we do a group by the user type and the gender. So, give me basically group every record by the user type, and within the user type, group it by the gender. And give me the count or the size of the trip ID column, and that'll give me this nice and pretty table here where it says customer female 18,000, trips taken, customer male 27,000, trips taken. Let's see, subscriber female 18 or 187, subscriber male 630. So this is where it's like the big jump, right? So 187 against 634 for subscribers. Customers, I'm interpreting this now that I see that there's actually customers who have a female or a male value in the gender column. This may be like one day passes. You may need to actually create a profile and they enter this gender field while creating their profile, compared to somebody who, I don't know if it's possible, uses a bike for one-time use and actually pays with a card or doesn't actually sign up for the app. So, the next question, what are the most popular stations where trips begin or start at, and where are the most popular stations of trips to end or finish at? Another group by function here. I guess I'm a fan of group bys. But basically, group by every station name, trip ID, and the count. I could have done station ID, but I actually wanted to know the name of the station because it gives you the street, so that was pretty good info to know instead of a number. And just give me the count of trip ID. And that gives us this. So based on the million records, Canal Street and Adams seems to be the most popular, right? So we have 16,922 trips where it was started from that station. And then the next one, so on and so forth. You see this Hubbard Street bike checking. There's one trip that is started there, so it might be actually not an actual station. Again, 7 million records. So if we actually took at the 7 million records data here, you'll see that it's a little bit different. So there's actually a Streeter Driving Grant has more trip IDs of from compared to if we looked at just the first million records. So that is good info to have. So with that, not that I wasn't satisfied with the answer, but it tells me what are the most popular stations, but if I didn't know as a user where Canal Street and Adams Street is, tells me nothing. So what I did was I utilized that volume to create a map. So I created this from trips count data frame, I guess. And the data frame is the longitude and latitude of trip and the count. So for every unique longitude and latitude, give me the count. And that, I reset the index to get because I'm going to need the index here in this length from trips count. And after I have the data frame, I just I rename the new column or the count column to actually say count. I think it says 0 if I don't do this, and then pass it as a float. I rename the count here, actually, yes. And here I'm just resetting it to itself as a float. Then I initialize this volume map. The location and everything, I actually had to play around with this a little bit just to make sure I got the right view, but this is the starting view of the map. And then this for I, so for every value I in range 0 to the length of from trips count, then for every value, add a marker, a circle marker, on the location. And the location is going to be latitude and longitude. So these are all the from trips. And the radius of the circle is going to be equal to, oh, don't act up on me here. Okay, it's going to be equal to the count, right, from trips count, oh gosh, okay, divided by 5,000. For the reason I did 5,000 is actually for the 7 million records, right? The more records there are, the higher the count is going to be, and the radius of these circles could be like ginormous. So if I run it like this, I'm guessing the actual circles are going to be a lot smaller than this. So let me run it. Yep. So you can play around with this here. Oh, that might be better. Might need it a little bit larger. So I'm going to do 750. See how that goes. Okay. So this is just gives me a quick map. I can navigate, move around, zoom out, and I can see, okay. So these are probably the most, based on this is where Canal Street and Adams, or Clinton Street in Washington. So if I wanted to find Canal Street and Adams, I can zoom in here and find it, right? So this is Washington and Clinton. And I can use the size of the circle, right? So it's Grand Avenue. So it's pretty nifty and just gives you a quick visual of this table, right? If you don't know what the streets and the locations of these, where these trips are starting from. And I did the same thing for that 2, right? So I said, now where are the trips typically ending at, or where is the 2? So unsurprisingly, where they're starting from and where they're ending at is pretty popular. And so the next thing I did, sorry about that. Okay, so let's see, where were we? So I did the same thing for the 2 trips, and I did pretty much a copy and paste, except we want to look, obviously we want to map these 2 in latitude and 2 longitude, and we want to do 750. Let's do 750. And ta-da! Oh, I can change the color here, so let's just change it to red. Okay, so not same map, but you know, same sort of visual that you get here. These stations seems to be the most popular. This one makes sense. The pier's right there, so I can see people going to the pier, dropping off the bike at this station right here, right? Similarly, I think, yes. So the metro is here, so this makes sense that these are the popular stations for the 2, as people are probably going there to get on the metro. So again, pretty nifty, and you can zoom in, zoom out as much as you need to, and look around. So that's neat. The next, what did I do here? Oh, yeah. So I was actually thinking, well, okay, now that I know how to do a map, I took a look at the station's data frame and basically said how many docks are in service, and then I created a map. And for this map, I actually took, so I did 2 things. I created a map with all the stations and mapped those, and then I created, I guess I shouldn't say map, I created a data frame with the top 10. The reasoning for this is that when I went to, so I initialized the map, and then I added all the circles, right, of this map DF, and then I went in and I said, for just the top 10, add another marker on top of it, and mark that color of the new marker as red. So this basically says map put a circle marker, right, on all the longitude and latitude of all the stations, and use the Dachshund service as the radius, and then add another quote-unquote layer on top of that with just the mapping just the top 10 stations with the same radius but a different color. And this gives us, let's see what this gives us, this map here. And the reason I like this one is because, well, I actually don't have the top 10 here because I changed it up here, right? Yeah, I did 5. But I only saw 4 circles. I was like, wait a minute, so what's happening here? So if I zoomed out far enough, you'll see that up here there's another one. This is all for the stations in terms of the docks, right? So I could do this also for like the from and the to. But you'll see that this Ravenswood station has, is part of the top 5. So surprisingly, I mean not surprisingly, I guess, because I think that's the first stop of the metro, right? So I would imagine Divvy wants to have a lot of docks in there so that people going to take the metro can leave the bike there. So that was a cool finding, and pretty cool that I was able to do that. Basically put two layers of circle markers, one of different colors, and it gives me this visual of different effects. That said, the next question, so I kind of rested my case on there in terms of, okay, so these are the most popular stations for taking, where trips are starting and where trips are ending. Trips by time of day. So for this specific question, where does it count for trips by time of day? I added 2 new columns, start time and a column end time, and I basically took the start time and made it into this format of year, month, day, hour, minute, seconds. Same for the end time, just to make sure that they're in date type format. And then after that, I just created a new column called start year, start day of week, start weekday, which is weekday and day of week is this quote unquote the same, but weekday is spelled out Monday, where day of week will give you a 0 for Monday and so on. And then start hour of day, and also start month here. Okay, so it's pretty simple. So I basically called the data frame trips start time column, and then this .dt.year gives me the year, .dt.month gives me the month, .weekday gives me the day of the week. So 0 day of the week, as in like 0 is Monday, 2 is Tuesday, 3 is Wednesday, and so on. And then .dt.day name gives me and you see it's a function here, or a method, so it gives me the actual name, right? And then dt.hour is basically this value, the hour that the trip started. So I did that. So I created those new columns, and I can confirm. There you go. So it's Monday, day of week 0, Wednesday, day of week 2, as expected, right? Then I created this graphs list. Is just basically the list of the years that I want to graph. So for every year in graphs list, create a new data frame called basically a view of trips data frame, and this new data frame, set it equal to the start year. So basically pull only where the start year is equal to I, or 2018, and when the second loop runs 2019, and then set that same data frame equal to group by. So group by start hour of day, and count the number of trips for every hour of day, and then plot it. So this plot equals to graph df, which is the temp data frame for this loop, dot plot dot bar. The x-axis is, or the x values are going to be start hour a day, and the title is trips at each hour a day for I, which is the year. So if I run that, it'll create these 2 charts. So you'll see a pretty standard, when I say standard in very loose terms, what I anticipate is rush hours, right? So we have these 7, 8 rush hour for the start of the day, and then this 4, 5 p.m. I guess close of business rush hour, and that seems to be pretty similar across years, right? So there's not a lot of differences. It might be just the count, right? So the count might be different, where here it's just a tiny bit different, a lot higher than 2018 for that specific hour of the day. But this is in general. So this includes weekends and weekdays, right? So then I was like, okay, well, with that in mind, let's just look at data for weekends only. And I did the same thing, a for loop, but I also in this specific line of code, I said where the start year is 2018 and where the start day of week is greater than 4. So if Monday is 0 and Sunday is 6 and Saturday is 5, so if it's greater than 4, it's going to be either 5 or 6, which would be the weekend. I run this, and it says a weekend trip count, so it's dramatically different, right? So there's not a dual peak here. It's just one peak at 12 p.m. and then one peak here in 2019 at 3 p.m., which is interesting. And again, we're only looking at 1 million records, so if we take a look at this specific data in the 7 million records, you'll see this looks pretty similar, right? But then here you'll see, okay, so 3 p.m. is not actually the peak. The peak here is about 1 p.m. Whereas here, 3 p.m. for 2018 seems to be the peak. So the more records you have, obviously, I think the more symmetrical it might be. And it may be so that the first million records we imported, we're looking at specifically just maybe the first 3 months of each, or the first month of each quarter. Okay, so with that said, I looked at weekdays, similar process, and interestingly enough, there was no difference. I don't know why I said interestingly enough. Okay, so then I don't know if I just wanted to outdo myself, but I created this for loop. I added this day of week list. So for every year in the graph list, I should probably name this year list. And for every day and for every year, create a plot, basically plot a bar plot where the year is equal to I and the weekday is equal to day. And this was just a fancy way of saying, actually, for these are all weekdays, Monday to Friday. Let me just look at specifically Mondays for 2018. What does that look like? Tuesdays and so on. And so if I run this, it just goes through and loops and starts adding a new data frame. And you'll see, okay, so like Saturdays and Sundays, pretty typical in terms of the one peak, whereas the weekdays have that double peak, right? So same thing for 2019, Saturday, Sunday. Interesting here. Okay, again, this is only 7 million records, so if I look at the data for the 7 million records, you'll see that data here. You'll see it's a little bit more even, especially for the weekends, right? Like it just rises and falls at the similar rate than only 7 million records, right? There's some not issues, but discrepancies, and we could attribute it to the fact that we're only looking at 1 million records. Okay, so the next question, can we confirm the theory that trip counts are highest during spring or summer months in Chicago? So what I did, pretty similar to above, except we're looking at months instead of start or day of week. So I created this, and you see one of the quote-unquote issues with this is that we're only importing a subset of the first 125 1,000 records of each quarter, right? So we only got month 1 and a little bit of month 2, or quarter 2. So the first month in the quarter 2 of 2018, and the first month, and so on and so forth. So this doesn't really give us a good picture because we're only importing 125,000. So if I look at the what's it called, the 7 million records, then we can see, okay, this is a much better picture. Okay, so 5, 6, so May, June, July, August, even September, October, there's over 300,000 trips. But then in these winter months is dramatically less number of trips, right? And then 2019, interestingly enough, like it may just be based on the weather, right? So maybe 2019 just had, I guess, a more mild winter, so it rose at a rapid. The number of trips rose more rapidly than in 2018, where it just took a big jump from April to May. And usually in Chicago, April marks the quote-unquote end of the winter, right? Like, at least for St. Patrick's Day and Dying of the River and all that good stuff. So, and then we see like it dies down super fast at the end, similar to what it did in 2018. So this is a better picture than our shortened version here. But just, again, we have the code, so if we have the data, we just run the code and all the data, and if we have the computing power, then it'll be fine and well. Okay, so the next question here, what is the difference of trip counts of subscribers versus customers? So pretty simple bar plot. And I actually didn't use Seaborn, I just used pandas to create this bar plot. But I create a group by function, group by user type and start year. So I just want to look at customers in 2018, customers in 2019, so on, right? And then I plot it using this graph.plot.bar, give it a title, and then I played around with this annotate, because it usually gives you just the bar height, right? Like, okay, then this is about 3 and then 60, so 3 million, or 300,000 actually. With this annotate, it just adds the actual number to the top here. So just made it easier to say, okay, what is the actual difference between these two? So that is that. So if we look at that, it's pretty similar in the 7 million records for the full 2018-2019. You'll see that customer jumps, but the subscriber doesn't really jump a lot, right? Number of trip counts by subscribers, it's only about what, it's like 292, 293, maybe 10,000, but for customers there's dramatically a lot more, right? So it could be something that we can go down a rabbit hole. So for the sake of time, moving forward, what is the difference in trip count of weekends versus weekdays? So this one specifically, let's see. Okay, so this one I'm looking at weekdays, so I should annotate this trip count of weekdays, right? Because we're looking at anything where the start date of the week is less than 5. And I do this annotate, creates this bar plot. Not a lot of difference between 2018 to 2019. And when I say not a lot, I mean it's 396,000 compared to 398. So 2,000. Whereas then I do this for weekends. Should do the same. For weekends, it actually went down. So, okay, fascinating. Cool. And then I went ahead and did this for loop because I was really into for loops. But this actually gives you the trip count by start day of week. So basically where the trip starts, what day of the week, and then this is the kind of the overall trip count, right? Not the hourly trip count, but just the overall trip count by day of the week. So this makes sense, right? in terms of weekends. I guess if it's not like a business related use to get to work or to get back home, the weekends are going to be less busy with trips. So that confirms that theory. So at least whatever confirms mean. What is the average age of Divvy writers for 2018 and 2019? So writer age, this is actually a column that we had to calculate using this birth year. So to calculate the writer age, I just took the start year, so when the trip started, and subtracted the birth year, so the birth year of the writer. They didn't have a birth date, or else I could have done like an actual age, but this is just year minus birth year. So 2020 minus 2000, for example, then they were 20 years old. So I calculated that column, and then after that I just plotted it. Pretty simple too, using this seaborn count plot, similar to what we did above. You see it's left skewed, right? So the other one was by year, was right skewed, because as the year increased, the number of trips increased. This one, you have this right skewed, I guess, distribution where the bulk of the writer age is around this. I guess if I can zoom into this, I can make this, let's see what happens if I do this. Better. Yeah, 28, 29, 30, 31, 32, 31. So this aligns with our plot earlier. We see that there's this 120, which doesn't make sense, right? So somebody must have just scrolled all the way to the bottom number. So next, for this specific question, the average age, I went a little bit further, and I wanted to put the male versus female on the same plot. So for subscribers, actually, what does this tell me here? Yeah, by gender. So okay, so I looked just at subscribers. So I took a data frame, which is a view of trips where user type is subscriber, and then I grouped by gender and writer age. So for every gender and for every writer age of that gender, give me the count of trips. Then I have this quote-unquote master data frame with two genders and every writer age within that gender and the count of trips, and then I take a subset of that and set this male age data frame equal to the reason I created it to a numpy is because this plot actually, so basically the array, right? So .loc of graph df where gender is male and writer age to numpy, it gives me an array. So let me run this so I can show you what male age looks like. So it's just an array of the count. Oh, actually, so it's just an array of the age, and then if I run this male, it's actually a good refresher for me. Trip count gives me the corresponding trip count. So it's just two separate arrays, but we know that the first record here corresponds to the first record here, if that makes sense. I did the same thing for female, where gender is female, writer age, and then with gender is female, trip count. And then I plotted those specific arrays. So I created this figure size 15.5, which is 15 is the width, 5 is the height, and then plot male age, male age, which is the array of ages, and then male trip count, which is the array of trip count for each age. C equals red, which is the color of that line. Label equals male. setting this label here. Same thing for female, and then I went in and I set up the X label, the Y label, the title, and then the legend, and showed it, and that's what it does. So distribution wise, right, skewed, right, for both. You'll see this like what's happening here. Basically, it would be my question, like, why is this jump? You don't see that as, I guess, as a dramatic of a jump in the female line. So I'm curious whether people are going through their midlife crisis and they're setting a lower age, or something's happening. But so that plot was interesting, and actually it was fun to create it. I learned something new in terms of the NumPy array and how to use that to create this type of plot. So you have these two line plots together. Okay, what percentage of trips are over 45 minutes versus under? So this is just a printed out. So I calculated the total trip count and then the total trips over 45, and then I just divided and times it by 100. So 5% of trips are over 45 minutes overall. So that's in total, right, of the 1 million. Whereas if I go here, and by the way, here is like the 7 million, you can see that there's somebody age 250. It's obviously if I were to actually run a model of this, I want to make sure I get rid of the outliers that I'm working with, at least specifically because nobody lives to be 250. But anyways, for the full 7 million record, 6% of the trips are over 45 minutes. So that's, I don't know, I would say that's pretty significant, right? 70,000 is 1%. So anyway, so in terms of further diving down out of those 5%, right? So let's say, what is the percentage of trips over 45 minutes by user type? It's pretty simple in terms of how I went about it. So similar to that up there, I just did it for both types, right? Subscribers and customers. And I got that 0.85% or 865 of subscribers went over 45 minutes. So as expected, I guess align with our theory, not as expected, but align with our theory that typically subscribers, because the subscribers, in my understanding as a user, is that they'll get a 45-minute trip for free, quote unquote for free, right? You're still paying for your subscription, but after those 45 minutes, you get charged per minute. Now, you could check in your bike into a station and check it out again, and that's a second trip or a different trip. So not very many subscribers go over the 45-minute mark. It just doesn't make sense, right? Because you're already paying for a subscription. So out of the 1 million records here, 7,000 went over that 45-minute, whereas in the 7 million, only 55,000 trips went over the 45 minutes by the subscribers, whereas 27% of customers were over 45 minutes. Of the 1,047,000. So I'd imagine of the 7 million, it's still pretty high, right? 27 points. So it didn't even make much of a difference. Customers are still going dramatically a lot over 45 minutes. And that is to say, like, customers, I believe, if you're not a subscriber, you get 30 minutes, right? Or you can get like a day pass. So that may be the reason that they're going over the 45-minute mark. I don't have the business context or the access to, so I'm assuming a lot of these things, but for 120,000 out of 7 million, that's a lot, and especially if you start charging people by the minute, this could add up real quick. And I guess it would be interesting to dive down into that demographic of who's going into this over the 45-minute mark, and anything that is costing, like what kind of, I guess, where are the stations that these are coming from? Where are the stations that these actually, where they're coming from or where they're going to? Because maybe it's worth it adding more docks, right? Or maybe the reason they're going over for 45 minutes is because there's not enough docks. So maybe it's not worth it adding more docks. So there's a lot of ways that you can take that. So the same thing for male or female, or over 45 minutes. So after after this code, I got pretty lazy and I was like, well, I don't want to write this over and over again. So I created this method, get ratio trip, where you pass in the column name, the value, the column name, and the second value you want to compare. So for example, I passed in this gender, male, trip duration 30. So give me the genders where the gender is male and the trip duration is greater than 30. What is the ratio compared against the total trip count? Same thing for gender, female, trip duration is 30. So I did that. Name trips is not. Wait. This is my master. No. Okay. That's not good. Okay. So I'm actually going to. I'll leave it. Where are we here? Okay. So I run that code, and it tells me that males were over the 30-minute trip duration, or 5.28% of trips were over 30 minutes by males, whereas females 9.21, so almost double. For male, 1.65 over the 45 minutes, so still almost double. So females seem to be over that 45-minute or 30-minute trip duration mark more often than men, which is interesting because they're taking less trips, but they're over more often. So, but their trip duration, I guess, is longer, but on average, right, 18 minutes. So, yeah, something that we can dig into deeper if we had access to data and context. So the next actually created this, so similar to what I had above here, but just for the 45-minute mark. So I wanted to see, does it look different for over 45 minutes, right? So people who go over the 45-minute mark is generally younger people, but it seems pretty similar to above, right? The only difference is that this spike is almost the same for both. Even though females are taking less number of trips, the count it's dramatically higher. So it's, again, fascinating, something that we can look into in more detail and try to figure out if we can predict if a given, I guess, the number of trips are going to go over 45 for females and males, right? Anyway, so the next one, I just use that same method that I created above and call it for, say, give me the ratio of trips over 30 minutes for 2018 compared to 2019. And you see that it goes up, right? So 2019, more trips were over the 30 minutes and not as much for over the 45 minutes. And this is irrespective of subscriber or customer. Whereas over here in the 7 million records, you'll see similar, it's about 1.3% jump, whereas over in the 45 minutes, it's very, I mean, it's 25,000 out of 7 million, right? Still adds up, I guess, but just an observation. So that was it for EDA. Then we did some additional exploration. First, I mean, this is pretty straightforward, and I know we're running long here, but correlation matrix. Basically looking to see, is there any correlation between any of the columns that we have. So if I run this, correlation equals trips.core, it's the easiest way to get a correlation between each column. And what I like about this is you can use this style background gradient, CMAP equals cool warm, and basically gives you the data frame, right? But it highlights the cells based on the value, and you're able to more easily pinpoint, like, okay, this against gender and user type, or if we're looking for, is there a correlation between, well, there is, between writer, age, and birth year. Surprise. Now you could do a different heat map, something like this, where you use this seaborn.heatmap you pass the correlation data frame, you set the X tick labels to the columns, Y tick labels to the correlation columns, and this CMAP, this VLAG is, I believe it's the color, and then annotate true. So if I don't annotate, it'll just give me a blank, which is fine, but you're not able to say like what is this value and is it significant. So if I do annotate equals true, it gives me the actual, eventually here, there you go, the actual values, right? So I'm able to pinpoint, okay, I want to find 0.26 or something that may be significant correlation. It's going to be easier to identify here using both color and values. So in terms of what I found, I mean, there's nothing really strongly correlated. I was thinking is writer age correlated with duration and things like that, but nothing that you would say it's over 0.7, 0.8. That's where I would start thinking, okay, let's dive deep into that and see specifically if there is a correlation, right? This user type and gender. So it seems like user type, which makes sense, right? It seems like the distribution of male to female, it's actually not the same as the population. So there may be a strong correlation of user type and gender. But I don't know if it's based off of, again, multiple factors, right, that go into this in terms of whether they're marketing. There's some sort of bias in the application. There's some sort of bias in the way that the bikes are designed. And it's easier or just in general, like males are more likely to commute into the city and things as such of that nature. So a lot to dig into. Then I created this map of station use. So once I figured out how to use this map, I was like, oh wow, you could do a lot of things. So this stations, so all the trips where the stations initiate are the from, right, the starting stations. I'm looking at anything that is less than 5, so the weekdays versus the weekends. And radiuses, I'm setting the radius up here because I'm lazy and I don't want to change it down here every time. And then I basically say for the weekdays, give me a radius with a circle blue and red, and then I do that. And so it gives me, well, that's a strong radius here. Ta-da. Okay. So you see that the to and from, I guess actually from weekdays and weekends, they're both from. So weekdays, there's more trips for the majority, right? You have 5 days compared to 2 days. But like interesting, this here, even though mostly the ones that 5 to 2, this is almost the same, right? So you have these, and these are like the museum, Grant Park is here. So there's a lot of these stations where it's like, oh, okay, this makes sense. Like, oh, this is the start of, if they wanted to go for your bike right up here. So anyways, you're able to set it and graph both of those data frames into one map, and it's in a pretty neat way, similar to above. Similar for 2, really the only thing it changed is, well, the 2 longitude and 2 latitude, but everything is the same. So where are people headed? You see that during weekends, seems like people are not headed this way, which is not what I anticipated. Again, it's only a million records, but this is what this data shows us. Okay. So, going forward here, statistical analysis, or my take of a statistical analysis. For this specific one, similar to above, I did a plot of a count plot, right? So actually, 'Actually, this isn't a count plot, this is a histogram. So a histogram of, let's say, 100 trips, right? So you have 100 trips, and then you have 5 days compared to 2 days. But like interesting, this here, even though mostly the ones that 5 to 2, this is almost the same, right? So you have these, and these are like the museum, Grant Park is here. So there's a lot of these stations where it's like, oh, okay, this is the start of, if they wanted to go for your bike right up here. So anyways, you're able to set it day of week, trips by day of week, duration of trip, and you can see there's just a lot. Like this isn't, there's going to be outliers here. Writer age, and I'm setting the bins here. I'm still learning how to do this to get good at it and get deep insight from it. But I mean, from this I can see that the trip duration, there's some outliers where 250,000 minutes. You can get a specific that describe again, which is the statistics that we looked at earlier. So let me skip this before I. So there's this box plot which tells you, gives you the median, right? Gives you, well, I guess the mean, 25 percentile, quartile, 75%, 75% of. How can I say this? Percent, or the third quartile in it. Does that make sense? 75%, or this value here. So the first quartile, the third quartile, and then everything in between, it falls between those two values. And then anything outside of these whiskers are the, memory serves me right, they're the outliers. So there's nothing for start day of week, which makes sense. For trip duration, you can see like just there, I mean, 250,000, somebody forgot or took it home and left it for a year and paid for a year's worth of, or maybe there's just snicker finger data entry error here, but these are all outliers. So there's really 50,000 minutes. That's a lot of minutes. Writer age, similarly what we talked about earlier, 120. These are all considered outliers based on this box plot, right? So how these, I believe how these are calculated is 2 standard deviations from the mean is the end of this whisker here. 2 standard deviations from below the mean is this whisker here. So all these other values fall outside of that and are considered outliers. But for the t-test, so the way I understand this is you set a null hypothesis. So we're going to say that our null hypothesis is that, let's say, let's just do trip duration. So we'll say the mean trip duration of 2018 trips compared to 2019 mean trip duration. The hypothesis is those are equal. Now we set an alternate hypothesis, and we try to prove that alternate hypothesis, that this mean trip duration and the is not the same, or is greater than or less than the 2019 mean trip duration. So I set up this method for a run t-test where you pass in a field and a comparison, field comparison 1, field comparison 2, and then the aggregate field. So what that looks like is I'm passing the start year, which is the column, right? So I'm passing this field, and then I'm saying compare for the column start year 2018 against 2019, and the aggregate that we're comparing against is trip duration, so mean trip duration. And then I'll create a series 1, which is just a series. It says give me the series where trips field, which is the start year, is equal to field comparison 1. So start year is equal to 2018, and give me just the trip duration. Series 2, same thing, but for 2019, give me the trip duration. And then get the mean of the series, right? Series that mean S1, mean S2, and then run this test result. So run a t-test using penguin.t-test and pass the series 1 and series 2. And then print out the means and then return, because this t result will return a data frame with variables of like the p-value, the t-value, and such. So return p-value and the t-value. And I'm still learning about this, and I'm trying to understand it. But when I run this, I guess I should define it first. There you go. Where are you? Okay, trip duration. Okay, so when I run this, it says the mean trip duration for 2018 is 23 minutes. The mean trip duration for 2019 is 21 minutes. The p-value is 0.1, and the t is 1.6. So, from my understanding, if the p-value is less than 0.05, the difference is significant enough to say that the mean of 2019 is higher or less than, or the mean of 2018 is higher than the mean trip duration of 2019. But if the p-value is not less than 0.05, then we don't have enough evidence to reject the null hypothesis, which is to say we don't have enough evidence to reject the hypothesis that 2018 mean trip duration is the same or equal to 2019 mean trip duration. So we can't accept that they're the same or they're equal, but we don't have enough evidence to reject it. And that's how I understand this t-test. So we don't have enough evidence to reject that the trip duration for 2018 and 2019 are the same or different. So I can actually, let me see if I can run these. Okay, so I ran a t-test for 2018-2019, minimum distance traveled. The p-value is less than 0, so we can reject the null hypothesis. That is to say, we can reject the hypothesis that the mean minimum distance traveled from 2019 is the same as the mean minimum distance traveled for 2018. So we're saying that they are different. They are significantly different, I think. Please do tell me if my thought process is wrong, or I need to correct something, because I'm still learning about this and I'm trying to understand. So it doesn't have to be year. So for example, here I ran it on male, female, and I don't know if I'm actually doing this right. Let's see, male, female, right range. Okay, male, female trip duration. So is the mean trip duration between male and female significantly different? So the mean trip duration for males is 14.5. The mean trip duration for females is 18.79. The null hypothesis is 14.5 is equal to 18.79. When we run this t-test, the p-value is 0.0003 and the t-value is negative 4.7. So the p-value is less than 0.05, so we can say that the alternate hypothesis is true, and we can reject the null hypothesis. So that is to say that the mean male trip duration is for 2018 and 2019 altogether is not equal to the mean female trip duration. Okay, so that was a lengthy one, but well worth it. Okay, so thank you so much again for watching. If you watched it all the way, if you skipped around, it's totally fine. I would do the same. So with that said, be on the lookout for any updates on data visualizations and such for this specific data set, because I'm going to extract my data and see if I can create a dashboard. Anyways, thanks for watching.